Alright, here it is. Our Chemical Sciences complete DIY guide to building your own Thunderstorm Generator and generating Plasmoids at home. We're going to reconstruct the Thunderstorm Generator from scratch, providing all materials and specs accompanied by the available schematics and instructions. And this video is really all thanks to the work of Nikita Volk, who's been prototyping and conducting experiments on the Thunderstorm Generator himself, and who published an open source document on the Martin Fleischmann Memorial Project website, which contain the diagrams and the models that I'll be using to show the build in this video. So full credit goes to Nikita for the visuals here, and I encourage you to go and print out his document to assist with your build and your trials after watching this video. Also, as usual, a huge thank you to Malcolm Bendall, the inventor of the Thunderstorm Generator and modern pioneer of plasmoid-based technology and science. He gave feedback on the draft for this video and provided us with more specifications and material data based on the most recent trials. And also special thanks to Robert Hutchings, another scientist who spent significant time working on the independent prototyping and research effort, who also reviewed my draft and gave feedback. My only disclaimer for this video is that I can only speak to the best of my knowledge. I am open source and completely independent of Malcolm and the tech. I may get something wrong. I'll not be giving deeply technical explanations in this video, just a simple down-to-earth build guide. And I also expect there will be many updates and improvements made to the Thunderstorm Generator prototype, both by Malcolm and his team and the independents prototyping this at home in the future. Things are moving really fast. So please also be aware that there are pending protection patents being processed for this technology, and you absolutely cannot try and patent any of this stuff yourself. The Strike Foundation's patents have been filed to keep this open source, and you're still very welcome to go and build one and work on advancing this technology yourself, find other applications. Everything's here and open source for people to build themselves and experiment. Secondly, I am not responsible for your life and safety. To the best of my knowledge, there's been absolutely no injuries or explosions from the Thunderstorm Generator prototypes that have been tested so far. Only implosions, which, although they are phenomenal and certainly have the potential to be dangerous, they've also only so far occurred within the metal spheres and influencing the metal spheres, as the implosions only occur when it's operating under vacuum. So no dangerous levels of radiation or any radiation at all or anything like that have been recorded in the tests so far conducted either. And of course, if you start playing around and replacing the water in the bubbler with other things, I have no idea. Maybe it'll become very dangerous. Depends on what you put in there. So everyone stick to what you know, and if you don't know much, stick to water, because that appears to be totally safe from all accounts so far. Again, your life, your safety, your decisions. This is the information we have. How does the Thunderstorm Generator function, and what does it achieve? I'll give you my own theoretical explanation in the next part of this series, based on what I've learned from Malcolm and others who've worked on the tech. And there'll be some brief explanations within here, but this is going to be really focused on the build. And if you're able to work metal, please go and build your own test unit in your workshop using my guide here. Perform whatever practical tests you're capable of doing on your build, and send me your results in video so I can share them with the community. Together we can really help verify and build on Malcolm Bendall's work and keep this open source. If you want to know more about what this thing is and why you might want to build one to experiment yourself before the next video, I encourage you to go and check out my other videos on these topics. I go through the science behind this tech from multiple perspectives already in those. But in this video, we're going to remain as practical as possible. Here is how you build this thing. Step 1, the UV air ionization unit. This looks mildly complicated, but it is not. The ionization chamber can be as simple as an opaque plastic container with a UV light bulb sitting in it, attached to the lid or the top of the container. And choosing a UV resistant plastic is going to be a sensible option for the obvious reasons. But Malcolm says that for optimum results, the chamber should really be made of copper or titanium. So if you're capable of working with these metals, this is the ideal material to use for the chamber. There may be some optimum size or geometry for the chamber, but if there is, this is currently an unknown and hasn't been considered as a factor in the initial prototypes. Ultimately, air is just being vacuumed through at the rate of the engine and the retrofit's capacity, so it likely isn't a major factor. For the specs of the UV light bulb that Malcolm's found most ideal for the prototypes so far, that's as follows. And these specs are taken from the presentation on the generator given recently in Zurich by Bob Grenier regarding the prototype they had there. And these UV lights or similar ones can be purchased online or at a local pet store. They're commonly used for reptile tanks, so you can get them quite easily. So the specs here that Bob gives are 300 nanometer wavelength, 4.13 electron volts, 20 centimeters, 25 watts, producing 45 microwatts per centimeter of UVB. And you should select a no ozone bulb. If you'd like to know why this is, please see my video on Bob Grenier's explanation of the tech, or the recording on the Martin Fleischmann Memorial channel of his full talk in Zurich. And a hole should be made in the bottom of the plastic UV ionization chamber, and you'll need to attach a vacuum-sealed pipe or hose here so that the air can be vacuumed through the ionization chamber and into the next unit, the bubbler, via the action of the engine's piston. Another valve is sometimes added here so that other things can be injected into the input stream if desired. And there's usually been another valve under the Plasmoid generation unit as shown here, but this has actually been removed from the new design as the water never actually needs to get changed out or anything. It just needs to be topped up by small amounts occasionally. Step 2, the bubbler or Plasmoid generation unit. This chamber is a little more complicated, but it's really still quite simple. And again, you could play around with the geometry or size here if you wish and see what you find. Our air gets vacuumed into this chamber through the UV air filter. The ionized air is vacuumed through the water and micronized into small ionized bubbles of water and atmospheric gas. The bubbles are pulled into the top of the chamber, and when the engine pistons reverse, the small bubbles symmetrically collapse, forming homeostatic structured plasma fields or plasmoids. The container should again be plastic and UV resistant. It needs to have a hole in the bottom for the ionized air to enter. Ideally, there will be a cone inside. It's narrow and culminating in the hole at the bottom so that the air can be well distributed through the chamber as it comes in. And you can do this in a number of ways, but what needs to be achieved here is this. So you should have a porous ceramic or stainless steel air diffusing stone. And again, find one online or at a local pet store. They're pretty common. The holes should be very small and there should be many holes, 100 microns or less. The goal here is to atomize the ionized air and get many very, very small bubbles. The bubbles can't be too big or they will not symmetrically implode in the next step. So there is an incredible amount of work that can be done here to explore and optimize this part of the process. This is just the very beginning. Next, you need to stuff some steel wool into the bubbler chamber. Stainless steel scouring pads, used for washing the dishes, apparently work well enough. Although again, there may be some advantages to using finer steel wool. You can try all sorts here. The idea is just to further atomize and micronize the bubbles, distribute them, break them up, make them fine. And you can work out your own design for this chamber, and you can even make some nice clean metal screens to keep the steel wool from flying around too much when you turn the engine on if you like. I think this was shown in some of Malcolm's original designs. When you're done, you can fill this chamber with around 1.5 to 2 liters of pure water. There needs to be an outlet hole to another pipe or a hose coming out of the lid of the bubbler, and all of this needs to be sealed tight to maintain a vacuum through the whole system. You'll also want to place a valve in this output line so that you can turn the input on and off without disconnecting the whole retrofit later. And if you do want to get nutty here, I have heard on the grapevine that people have played around with increasing the hydrogen content in the water just by gassing it in there and measuring it. It apparently does do something. Next, step 3, the Thunderstorm Generator unit. This is the hardest part of the thing because it requires some skill in metalwork. Precisely welding the joins for the spheres and the pipes is the most difficult part of the whole build, though a few of you who are skilled welders may find it reasonably simple to make up. For the rest of us, the first 25 pre-production prototypes will be sent out to teams all over the world for testing this month, and mass production models and parts should be not far on the tail of that. A quick note here that all the measurements for the Thunderstorm Generator should be made with the imperial measuring system. Using the imperial measuring system, inches and miles is integral to Malcolm's base mathematical theory, and in ancient historical texts, imperial measurements have a direct correlation with the harmonic frequency spectrum based on the A432 cycles per second constant pitch, or universe pitch, or at least solar system pitch. You can see my videos on Sanskrit and fractal mathematics if you're interested to learn more on that anyway, and I've got a lot more to come on those topics. So the pipes and the tubes. We're going to use a 1-inch and a 1/2-inch pipe in our example build here, along with 4-inch, 3-inch, and 2-inch spheres, as this is the sizing that's been used on all the original small-scale prototypes. 1-inch and 1/2-inch pipes are the smallest recommended diameter to not damage a standard size engine. The next size up that could be used would be 1.5 inches and 3/4 inch pipes. Malcolm has given us a list of the engine sizes that have been trialed so far using the 1-inch and the 1/2-inch pipe diameter retrofit, which I'm showing here. So if the engine you want to install on is somewhere in this spectrum, then you should be good to go. But he says that the most optimal and consistent results so far have been achieved with the small units, have been on a 310cc Honda motor. So if you're purchasing a new motor to install a standard size retrofit on, this should be your first option. The pipes need to be able to withstand a fairly high temperature, up to about 600 to 800 degrees potentially. Copper pipes from any hardware store are fine, but something non-ferromagnetic that distributes, and non-paramagnetic ideally, that distributes heat better would be ideal. So tungsten is Malcolm's theoretical gold standard, and it has very suitable properties, apparently. I also heard secondhand that Bob Grenier believes platinum could yield some interesting results. And there's many different aerospace alloys that can be tried here if you have any experience there. It's not only about heat distribution either. From my understanding of the theory, the Thunderstorm Generator should ultimately be tuned like an instrument. So a flute made of silver gives a more pure tone than a flute made of stainless steel. The theory is the same here. We can theoretically optimize the Thunderstorm Generator by treating it like a musical instrument, tuning it to the A432 constant pitch scale and optimizing the purity of our resonant thunderstorm by experimenting with more interesting metals than copper, if we have those resources. Malcolm says that we need the pipe to be a length of 144 inches or a harmonic of 144 inches within this tuning pitch for any scale retrofit. So 144 inches is quite long for a retrofit for a standard engine, so we will choose an appropriate harmonic. 24 inches is the correct harmonic length for the 4-inch, 3-inch, 2-inch sphere build, so this is what we'll use in this example. So the pipe should be exactly 24 inches. Next, the spheres. So we need 2 sets of nested metal spheres. You can just use 1 set of spheres if you like, as in the initial prototype that I checked out on the channel, but it is apparently showing better and more consistent results with 2 spheres, 1 on either end as flow guides for the incoming vortexes. All of my previous comments about the choice of metal made for the pipe are also applicable for the spheres here. Spheres should be made of 304 stainless steel. This is the optimum material found so far. Regular steel is not a catalyst, so it should be avoided. 1.5mm 304 stainless steel is optimum for tooling and spinning, and 3mm 304 stainless steel is ideal for conventional welding. The easiest way to make the sphere is just to buy 2 steel half spheres and weld them together. They're an item you can buy at building supply stores, on Alibaba, eBay, Amazon. I'll be honest, I have no idea what they're usually used for. If you just Google stainless steel half sphere, you'll find a lot of them online though. Otherwise, the only seriously important factor to consider with the spheres here is that they need to be at a ratio of 4 to 3 to 2 to one another, or 4 to 3. So you have 2 outer spheres at, for example, 4-inch diameter each, and then you have 2 inner spheres that must be 3-inch diameter each. And the most recent prototypes have used a 3rd inner sphere as a flow guide for the inner vortex. So if you want to try this, you'll also need to make up another 2-inch sphere. If you can find another way to make a perfect metal sphere that's easier, do that, go ahead and share your idea with us. I've already been chatting to a few people who have some different ideas to, either mill or cast different metals and try this. So it's certainly possible. Just remember that you need to nest the spheres together. So maybe just using halves is easiest for most people for the moment. And just to clarify, the spheres used in the small prototypes we've seen so far, they've been 4 and 3 inch spheres. And the size of the spheres on the large industrial retrofit done by Malcolm's team in the UK were 24 inch and 18 spheres. So the same ratio, 4:3. You can scale my examples there as much as you wish. Just maintain the 4:3 or 4:3:2 ratio between the spheres. So once again, insert my own experimental hypothesis based on Malcolm's theory. I believe the cavity of the outer sphere needs to be tuned to the note D in the A432 scale, and this is a perfect fourth above A, and a ratio of 4:3, and the middle sphere cavity should be tuned to the note A, the root note or the unison. And then if you're using the innermost sphere, the flow guide sphere, the cavity here should be tuned to the note E, a perfect fifth from A, or a ratio of 3:2. And if you don't know what I'm talking about here, just probably few people do, but many people should be able to make the connection. Don't worry about it. You don't need to do this to experiment yourself. It's just an extra Easter egg based on my own understanding of the theory. None of the prototype designs so far have been doing this, so you'll still get results. The spheres are simply a ratio of 4:3:2. That's all you need to do, unless you want to try and apply the theory even further and just see what happens. So let's quickly run through the layers of the Thunderstorm Generator step by step. You can reference all of the dimensions used in the diagram shown at the end or in Nikita's original document. So first we have the two inner 2-inch flow guide spheres, if you plan to include these. And these will need to be connected to support struts to hold these in place within the 3-inch sphere. These 2-inch spheres need to have a small pressure relief hole drilled through, as shown here. Next, the 3-inch spheres are placed around the 2-inch flow guide spheres. And as shown here, there needs to be a hole in either side of the 3-inch spheres, and a small piece of the 1/2-inch pipe needs to be welded onto one side of each here, which will then need to come out of a hole made in the same place on each side of the outer spheres to let that come through. The holes in the spheres should just be the size of the diameter of the pipe. The hole in the other side of the inner spheres is for the 1/2-inch diameter pipe that will connect the two spheres together. When you're working on your actual build, the 3-inch spheres, with the 2-inch spheres supported inside them, if you're going to try this, must be sealed and fully pressure tested before you continue on to seal them within the larger spheres, as from that point on there isn't really any going back. The inner pipe needs to be slid through the outer pipe and welded onto a hole in one side of each inner sphere. And then we just do the same thing for the outer pipes and spheres. The two sides of the outer spheres need to be placed around the inner nested sphere and its outlet pipes, and welded to the outer pipe in the same way that you did with the inner spheres and pipe. The outer 4-inch spheres are placed around the 3-inch spheres, and you can see that the hole for the 1/2-inch outlet and inlet pipes to pass through is made on one side of the outer sphere, and there's a hole in the opposite side of each sphere for the 1-inch diameter pipes that connects the two outer spheres, which will of course have the inner 1/2-inch pipe nested within it. Regarding the next part, you can choose to do without the precise angle of the transitions recommended, if this is a really limiting factor for you. They're really difficult to construct from all accounts I hear so far, but if you are able to make them as specified, that's great. The theory certainly suggests that following the harmonic mathematical guidelines is a good idea and will produce closer to optimal results. And I heard from some of the guys who've worked on it that, yeah, you can potentially get no results if you don't make at least some of these dimensions and transitions correct. If you're going to go ahead and attempt these transitions, the angle of the transition between the spheres and the pipes should be 51.84 degrees, according to Malcolm. You can see that you would need to make up a transition piece of this angle out of the same metal you were using for the spheres of the pipes here. So you should end up with a small pipe connected to a small sphere at either end, and a large pipe connected to a large sphere at either end. The small pipe and spheres are nested within the large pipe and spheres. All your joins need to be clean welds and maintain the vacuum. You can experiment with the angle of the input and output from the small spheres here if you have your own ideas. This inner sphere is intended as a flow guide to assist the cold counterclockwise vortex of water gas, vapor, and plasmoids that will be pulled through from the previous chamber on the vacuum cycle of the engine. So the small pipe coming from one of the small inner spheres needs to be plumbed to the Plasmoid Generation Unit. Again, make sure your seals are tight. How do you wish to do this? There's plenty of standard ways to create a good seal, and I'll let you use the established conventional methods here and apply your own knowledge of standard engineering and plumbing to do this. You do need another hole at an angle in the side of both outer spheres, as shown here. And obviously, all these holes should be made before you start putting your spheres together. In one of the outer spheres, this will be the output for the final exhaust stream, which is primarily oxygen and atmospheric levels of noble gases, as we've seen in the previous gas analysis trials here. And the hole in the other one is the input for the motor exhaust to enter the generator. And it's placed at this position to guide the flow of the hot counterclockwise vortex that's streaming in from the exhaust. So you need to weld a short length of pipe to each of these holes in the outer spheres. An additional pro tip from Robert Hutchings here, it's better to weld the exhaust port tubes to the 4-inch half spheres to easily maintain tangent alignment before welding it together with the other 4-inch hemispheres. Minor leaks in the exhaust side are not as critical, but pressure test with the soapy water and fix any leaks before continuing. The hot input and output streams come into and leave the spheres at an angle to the opposing cold vortex due to this arrangement. And that's about all there is for the retrofit build. We really just need to fit it to the engine now. So step 4, connecting the retrofit to the engine. The output pipe of the inner sphere needs to be plumbed into the engine between the carburetor and the motor. This can be achieved by precision milling an aluminium block for this purpose. It should be as absolutely precise, machined, flat as possible, as this is a weak point in some of the existing prototypes and often a cause for the dreaded vacuum leak. So if you've experience with altering engines and have other ideas that could work, are easier, more effective, feel free to leave a comment with your idea or let us know how you go trying if you're trying to attempt your own build. Turn the choke of the carburetor on, restricting airflow, and if you're having trouble getting the engine going with a retrofit later, you can play around with the airflow a bit here still while you get things going. It's up to you to find an optimal balance for your design, whether that's no air from the carburetor or some restricted air to get a better fuel air mix for your particular engine or retrofit. So you can play around, use what equipment you have to analyze what's going on from your own experience. A quick note, the fuel tank has been moved or replaced on many of the prototypes I've seen to make access and fitting the retrofit a little easier. And in some cases, it may be necessary to move the fuel tank to fit the sphere neatly next to the exhaust, which seems necessary here. You really want that. The output from the engine's exhaust then needs to be connected and vacuum sealed to the short pipe we welded to the outer sphere on the same end of the apparatus. And that's really all there is to it here. Triple check your seals, test the vacuum beforehand if you have the appropriate equipment. Maintaining vacuum really is all important. I know I've said it 100 times, and you'll probably know it from normal experience with engines. So this is just the same. It's an extension of the engine. It's all got to be sealed tight. Step 5, running the prototype and conducting trials. There's not much you need to know here. 1, start your engine as per normal procedure with the choke on and the valve inline from the Plasmoid Generator unit closed for now. Open the choke as per normal operating procedure to allow regular airflow through the carburetor once you've got your engine started. 3, allow the engine to run for a moment, minute or so, few minutes until it's warm and running smoothly. 4, simultaneously close the choke and open the valve to the Plasmoid Generation Unit. 5, you can play around with the choke a little to allow some airflow through the carburetor if your engine is struggling. So try find an optimal balance if you're troubleshooting. The likelihood of needing to open the choke can be minimized by finding the optimal metric between the retrofit and the motor so you're getting appropriate airflow. And this can be done somewhat intuitively just to find a starting point. But as I say, they are designed based on different mathematical principles, and this has so far been pretty hard to reconcile, and there's no specific metrics here. So I wish anyone who thinks they can find out more the best in their attempt to gain more data, and I encourage you to share it with us all. 5, you should be good to go. Start paying close attention to any test equipment you have prepared, and if you built it as I've described here, you will see your exhaust gas readings of carbon monoxide, carbon dioxide, and hydrocarbons go down to practically nothing, among other things, if you have better equipment to check. You'll also see a dramatic increase in oxygen, and if you have the ability to detect the noble gases nitrogen, argon, they'll all be at atmospheric levels. And these have been the independently verified results so far being received from Malcolm's current prototypes. As far as fuel efficiency goes, increases. I'm awaiting several scientists to publish their analysis of this. On the grapevine, I'm aware that results ranging from about a 13% increase in fuel efficiency under load and somewhere about a 50% fuel efficiency increase not under load have been achieved in the previous prototypes. So I'll be really interested to hear your own results of testing under load, anything that you've changed about the prototype, and I'll continue to share the results of the trials conducted independently on Malcolm's prototypes by a few teams of scientists now around the world as soon as they get published. Step 6, theoretical advancement of the technology. So I'll leave you with a few ideas for future advancements of Malcolm's Thunderstorm Generator that I feel are worthy of merit, and most of them are from Malcolm himself and are mapped out in his long-term plan for the technology. He's prototyped several of his more advanced energy ideas in some ways, such as the static Vajra turbine already, and his world power plant that should be potentially underway pretty soon. But first of all, a lot of people don't seem to understand that this is a transition technology, or it's planned to be, for existing combustion engines. That's handy, we're able to convert something we already have with not many more resources, make it more efficient, solve some problems that some people are foreseeing. There's a lot of advantages to that. But what does the tech really give us? It shows us that we can transmute elements on an atomic level using simple, safe materials and widely available parts. And this is huge. A few things have already proven this before, but this is doing it quite reliably, quite easily, quite verifiably. So if this doesn't begin to inspire some really cool ideas further, I'm really not sure what will. I'll just leave you with that one. Malcolm's been publicizing one invention which has the ability to split hot and cold streams of air already, the Ranch Hills vortex tube. So think about that one. What makes the Thunderstorm Generator magic happen? The differential between the opposing hot and cold vortexes, among other differentials. So if you can create that temperature differential without a motor, well, you would be one clever fellow. And you still need to emulate the precise measuring cup and release of the motor's pistons, because that also appears to be an important factor. But I'm sure we can begin to bridge this problem fairly easily if we consider it carefully. So if we can transmute elements cleanly and safely at an atomic scale, we can change the world. Malcolm's contributions to the field of physics have the potential to completely transform our trajectory to a far more abundant paradigm. What's really important to understand here is how a thunderstorm works and what plasmoids or ball lightning are, opinion. So this is what we are going to thoroughly explain in the next video, thunderstorms and plasmoids. Thanks for watching. I hope you enjoyed this. I hope it helps you getting out there, building a prototype, whether you're a home experimenter or a scientist. Good luck. Thanks for watching. Stay tuned for part 2.